Everyone, welcome back to EduVibe. Today we are conclude the unit which is 1D kinematics with some extra question of the each topic which we done in my previous lessons. If you skip any lesson, check the playlist link in the description to check out all the lessons which we done of this unit. Today we deal with the extra question of the each topic which are very important. So let's move on to the first question. Says that the pitcher could uniquely throw a fast ball at the horizontal speed of 160 km per hour as verified by the radar gun. How long would the ball take to reach home plate, which is 18.4 meters away? So in this question, they mentioned that the speed over there, we have the speed of 160 kilometers per hour. We have to be in speed of in meter per second. This is kilometer per hour. So we have to convert this into meter per second. To convert this, we have to do 160 multiply by 1000 divided by 3600. When you do multiplication of this, you get about 44.44 meter per second. You get your speed in meter per second. V is equal to delta d upon t. Speed is given. We have delta d, which is 18.4 meter away. You want the time, how long it take. So calculate the time, so you do delta d upon v. So you know that our delta d is 18.4 meters and our velocity is, our speed is 44.44 meter per second. Meters cancel out and we get a time of about 0.414 seconds. This is 3 digits. So this is your answer. This is the time the ball would take to reach the home plate, which is 18.4 meter away. So time is 0.414 seconds. Move on to the next question, which tells that the electron moves from a position that is 4.20 mm below an origin to a position that is 11.5 mm above the origin in 480 nanoseconds. Determine the velocity in meter per second. So in our lessons, when we do the example question in every lesson, so we do not deal with any question which has the different units. Like in this, we have different units. Like we have in speed, this is like a distance, which is mm, and they want the final velocity, which we calculate the velocity at the end, which is should be meter per second. We also have a time in nanoseconds. So we have to deal with first the units first. We have to same the units of the all things, and then we have to calculate the velocity. So here we have two distances. One is 4.20 mm, which is below an origin. If there is a below an origin, so it's a negative one. So it's a below an origin. If we made that, if they thought about the origin, if we made some kind of graph like this, so if this is the origin, so this is in the below over there. Something in 4.20 mm is below this. So this will be negative form. And this should be initially, so that's why there are two 11.5 mm above the origin, and the 11.5 is above the origin, so it's a positive 11.5 mm. So in that case, we have that di is equal to minus 4.20 mm. We have to convert this into meters. To convert this into meters, we know that if we convert this, so 1 meters is equal to 100 mm. And if we skip that point and we get 100, 200 both, and that mm cuts out, and when we calculate this all, we get about minus 0.0042 meters. So this is our initial distance, or we can say the initial displacement. We have to find the final displacement too, and this is 11.5, and this is in positive because it's above the origin. Same thing we deal, 1 meter is equal to 100 mm. And when we skip that point, we get 10 like this. And when we cut mm, we get about plus 0.0115 meters. So we get our final and the initial displacement. But we want at the delta d for this because we know that with the velocity we have that delta d upon time. So we want that delta d, which is final minus initial. So the delta d is equal to final displacement minus the initial displacement. So this 0.0115 meters minus and again minus 0.0042 meters, we get about 0.0157 meters. So this is our delta D, which we put over there, which is 0.0157 meters. Now our time is 4.80 nanoseconds. So in your data sheet, you have some units like nanoseconds and other odd units. So that nanoseconds at n small n denotes the which value? It denotes the value of 10 raised to power minus 9. So you can just write 4.80 multiply by 10 raised to minus 9 and seconds. So you get the time in seconds now. You get the value of n from the data sheet. And now when you divide this both, you get about positive 3.27 into 10 raised to power 6 meter per second. And it's like we take above as positive, below as negative, so it's above, or we can say it's upwards. So from here we will get the velocity of about 3.27 into 10 raised to power 6 meter per second upwards or above the region. Next question. An object initially moving upward with the speed of 9.50 meter per second, which is about 9.50 meter per second, then experiences a constant acceleration. So they mentioned directly that we have the constant acceleration which is downwards. So if we take upwards of positive, so we take downwards is negative. So our acceleration is equal to negative 1.6 into 10 raised to power meter per second square. Then how much time? Again we calculate the time. Would it take to move up to a maximum displacement, come to rest, and then come back down to a position that is 4.00 meter above its original position. So from all that English work, we deal that our distance is 4.00 meters and we have to calculate the time. We just have to calculate the time from here. But they didn't mention that it comes to rest. They mentioned that it comes to rest, but again they tell us that it come back to a position where is that original position is. So this not means that our final velocity is in 0 meter per second. This means that we have to calculate the firstly final velocity, because we know if we have only one formula which we use in the final initial and acceleration, which we use in this formula. So we have to this formula again in this, like time is equal to final minus initial upon acceleration, which is acceleration is equal to delta v upon t, which we isolate the t from there. From here, if we know that what is final, so we calculate the time from here. So to calculate the final, we have to use the another kinematic equation or anything else we have to calculate. So these are questions coming, like we have to use the equations twice. So in this, if we deal with this one, Vf square is equal to Vi square plus 2AD. So from here we calculate the final velocity. So calculate this. So we know that this whole square, because the square when goes over there because the full square. Vi square is about 9.50 square plus 2. Acceleration is in negative, which is 1.6, and our displacement is 4.0. Our final velocity is equal to, when we calculate this, is about 77.45 whole root, and we get about 8.8005 meter per second. Now this is the thing. I put this in negative. So why is this in negative? Because when you see that it our this is the upward. Our initials goes upward, like up to this, and then it comes down. Is on its original position. They mentioned that it comes to maximum displacement and then comes to rest over there and then again come back to its original position. When it goes to original position, it goes downwards. So the final velocity is downwards. If it's downwards and with downwards is negative, so we have to get this in negative. If you want, so you can write over there that this was in downward direction. So downwards. Now here the final is 8.8 something we have to write in the rounded value, but we have to rate that not the rounded value, we have to take this value to calculate the original answer. It varies the answer if we take that rounded value. And we have initial velocity of 9.5 and we have acceleration of 1.6. So time is, when we calculate this, when we subtraction and then divide, we get about 11.4 seconds. So this is the time that take to come back to his original position after maximum displacement of 4.00 meters. Is about 11.4 seconds. Let's deal with this. So they mentioned that the rock is thrown upward at speed of 15.0 meter per second. We take the rock and thrown upward like this. So it's at the speed of 15.0 meter per second, it goes upward, so it is positive. So this means this is our Vi. And we have to determine what to this maximum height we measure from is release height. From the release height, when we release from here, what is the maximum height from this to this? We have to find that maximum height. So if it goes like our maximum height at over there, so it's something is the final velocity in this. So which they don't mention. So the final velocity is 0 over there. And some acceleration goes over there, because when it goes up, the acceleration goes downwards. So it's a negative now. This is 9.8 minus 9.812 meter per second squared. And we have to find delta D, which is also the maximum height. So how we can calculate this? Yeah, we calculate the same formula which we calculate in the previous question. Vf squared is equal to Vi squared plus 2AD. We know that V squared is 0, Vi is 15 squared plus A is minus 9.81, and D we have to find. From there we calculate this, that when we do 0 and when we go solve this, 15 squared, which is 225, and we goes over there, you guys, minus 225 is equal to minus 19.6 D. And we want D, so it's minus cancel out, and when we solve this we get positive of 11.5 meters. So this is distance from here to here of about 11.5 meters. It goes upwards, so that's why it's in positive. So this is the A part. We have to solve the B part too with the same information. How much time would it take to go up? So how we calculate the maximum height from here to here. Now we have to calculate how much time it goes to go up and returns to original height. And they also return to original height too. So how can we calculate this? We have to calculate the time now. We have the same things. We calculate the Vi. We have Vi Acceleration remains the same. Now at this time, our final velocity should be like different, not the zero. Like when we go through from here to here, when it goes to over there, so something will happen when it goes down, it's done with the same velocity. So when it goes up with the plus 15.0 meter per second. But when it goes down, it's in minus 15 meter per second. Because our time is varies. So time goes up and we have to find the turn time too. So this means that our initial and the final will be the same. So when we calculate this, like t is equal to vf minus vi upon acceleration, we calculate the number of times this formula. You can know that how can we get that t is equal to this. So our final is 15 minus 15 and our initial is 215 plus 15 now. And this is we get 9.81. From here we get our time of 3.0 seconds. So this is the time. How can we take the final of this? Because it want to be a go up and return its original height. So this means that our initial velocity and the final velocity should be the same in that case when we calculate of this. So that's how we can calculate this. So this was the last question of today's lesson. This was like a very we can say that this is a tricky question. Like this is what question which is like you have to know that type of questions too. So what they say in this question, on the moon gravity is 1/6 that of Earth. If we go on the moon, so it's a 1/6 gravity of the Earth. When a rock is thrown straight up on the moon, when we throw the rock straight up, it takes 18.4 seconds to return to its release height. When we throw the rock, like we throw the rock upwards, so it takes 18.4 seconds to come over there again. So you have to calculate the maximum height which they go up. So this means that the 18.4 seconds is the total time of this. So this time is up and down too. It's the total time, up and down time. So it's 18.4 seconds. When they go up, they go with some initial velocity, and when they at least come at that point too, then it has some final velocity too. That final velocity should be zero because they didn't mention, but we come to the initial velocity too. So the final velocity is 0 meter per second. Our acceleration is 9.8 meter per second. But this time, acceleration should be 1/6 of that, because this acceleration is from the Earth. This acceleration, when we throw the ball upwards, the acceleration is the backwards is in about 19.8 meter per second. This one. But when we're on the moon, so we have to get a gravity of 1/6 of this. So our acceleration is also the 1/6 of this. So you have to divide this by 1/6, which is about minus 1.64 meter per second scale. So this is the acceleration on the moon when we throw the ball on the moon. And we have delta D of about, we have to find the delta D, maximum height. But here's the thing also that the time is the total time up and down. We want only the one, we have to calculate the from here to here only, not the twice one. So we have to divide this by 2 to get the time of only the from this to this, not for the both. So when we divide this by 2, we get 9.2 seconds. So here's the thing, we don't need a VI, because if we take the VI of 0, it doesn't matter. It's like a not right, because it's some speed to be there when we throw the ball upwards. So that's why we take the VF 0 meter per second. But we deal with only the final one because we have the formula too, which is final velocity into time minus half AT squared. From here we calculate that out. What's the distance for this? From here, when we calculate the final is 0, so it cuts out with time, so it gets, that's the answer like this. So minus half, acceleration we take minus 1.64, and time is 9.2 seconds squared. And when we calculate the distance, we calculate about 64, no, it's 69. This is 9.405 meters. Also, if we need only the figures of 3, so it's 64, no, 69.4. So that distance we calculate from the down to upwards, so it's upwards distance. That's how the distance, the maximum height we have to calculate from the that point to the that point. So that's how we can deal with the gravity questions. We have to take the acceleration of one system, but that there's a differ. If we go to another planets, so that one system was like another ratio of this. Not only the one system, or one system only for the moon. So this one question you have to deal with if they come in the exam. So you have to take the acceleration of the one system, and the time is of half. If they mention that, this depends on the question which you deal with. So that's the completion of this unit. So we completed the whole unit of 1D kinematics. We completed all the lessons. We cover the examples separately to in the each lessons, and today we deal with the questions which are like very important from the exam point of view. So we completed the unit. We completed the first unit of K11 physics, which is 1D kinematics. We will move on to the another units too of the K11 physics, but in my next video of physics, we are going to start the grade 12 physics. So at grade 12 physics, we will start with the first unit, and we go with all the units in by the detailed explanation and the examples, and also the extra questions at the end. So that's all for today's video. So learning made simple with EduVibe. Learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any question, let me in the comment section. And this only thing that our grade 12th physics is going to be start in the first week of February. So we will see that grade 12th physics first unit from the February first week. So see you in the next lesson. Till then, stay connected with EduVibe.